Okay, thank you and good afternoon, everyone. My name is Janne Ruokonen, and I have also Jussi Jurvanen with me, but I have also two my brilliant students, Onni Liponkoski and Santtu Malinen with me. A little bit. My things is a little digital twin in the teaching of climate-resilient forestry. This next digital twin has been developed in natural precision felling project, felling to closer forest management. So what's that mean? We have in Finland, we have all forest is large scanned, and every trees places knowing that large scanning, but we have developing that better model. So our model is every tree is exactly same sizes and same places to our simulator, so that diameter and height is exactly right. What does climate resilient forestry mean? We have an example where the edge of forest, the felling area needs to be treated to climate resistant manner. How that is done? So our students maybe tell about a little bit that.
Yeah, so what we are doing here, we are doing climate resistant forest cutting, so we think about the sunlight effects on there and wind, and so we take the spruce woods, what are roots are in the top of the ground. So if there is felling area, so the spruce have roots on top of the ground, and if there is storm or something, and if we leave them there, they are gonna fall maybe next 1-2 years, so it's no good. And
actually usual when harvesting in forest, so we fell here about leaf grease, but now when we do to climate resilient forestry, we must leave here in leaf greens and remove spruce and pine. That's a very important thing understanding, and that's our project is the red thing is like understanding different mixed forestry, how that done, how to sunlight heating takes to wood and we must understanding better when we have a digital twin about Finnish forestry. And how do we do that? We are AI driver in guided maps. We can show to driver next level new things. In the maps, it's a brown. We called it this visible brown visibles to wolf trees. In Finnish, susipuut, but it's wolf trees because they are longer than rest of the forest, and they thus more prone to fall over to wind because this areas is 150 meters to 200 meters upper than sea level. So in Finland, that kind of areas, we have very much that kind of areas, and when storms coming, like nowadays, storms coming in this area, they are wet snow, And if we have bigger trees than other one forest, they are very dangerous to growing down. We can also find the digital twins data leaf green, what are lost their leaf green trees. We have a few small red things in the middle of on the map area. We can market that kind of trees to harvester operator, and they know that is remove trees or save trees, what we need to care about. And that data is digital twins best of digital twins data. What helps to driver. We have also our simulator more layers like groundwater's level understanding and the very many kind of things. And the suggestions of the roads being used machine have been prepared for us by AI. Prompts was to find roads 5 meters wide and 10 meters long, and that visible brown here map layers, and we must take new right prompts, and AI help us very much that thing. So, what covered forest treatment means? Actually, we didn't have tool this before. Nowadays, we can even teach the effect of the shadows on the choice of the wood, because digital twins makes possible tree shadows, and that helps understanding our very good. In the maps is blue market trees and red market trees. So blue market trees is very important trees to our red market small trees, because if we remove blue market trees, that tree market trees take a lot of sunlight, straight sunlight, and that not growing so good than that effect of shadows. And this digital twin with the simulator helps concretely understanding the shadows effect in the forest. We cannot have this tool before. Now we have. How we teaching about deal of an erosion sensitive area? We have very big hill, and we have water under of the hill, and we need understanding better to soil and what is how to deal with in this kind of area, and it's also occupational safety, because you can try where machine can drive and where cannot drive, and usually we strike a perpendicular slope to cross. Now we can trying other one, how to driving here, because we have digital twin, and it's understanding when you're driving simulator and understanding how to machine going in here. And how we do this, that digital twin learning environment? How first we fly about 50 hectares area in the drone with high pulse lidar, and we have also also photogrammet in multispectral camera. So then we get three layers here, 3D LiDAR and photogrammic and multispectral data. Then we stretch it in the world because every trees must be right places. And because trees growing about 150 or 200 meters upper than sea level, so it cannot be flat, it must be right places. And then we take this data to AI that separate us where's the spruce, where's the pine, where's the softwood, birch and aspen, where's that is. And then we get the data to XML format, because XML format is that easy because you can teaching AI reading about this data, and you can also create it to simulator world this XML data. But we have also two kind of data. We have XML in trees, and we have XML and to terrain. And that two data to Creanex create us about simulator world. But what else we do to our drone data, because in Finland every area is LiDAR, and we have 20 pulse per square meter to public data. But it's a little bit too less what we need, because we have 100 pulse per square meter. So we can teaching to AI take 4 times better in public data, so we get everywhere in Finland 80 pulse of square meter data, and we can create that XML everywhere of Finland. And when we get the data in a simulator, I build to learning environment, assessments, pedagogy, scoring, learning goals, things to be measured, making appropriately difficult choice with climate resilient choices. And every exercise starting same time. We have first pre-merger trees, then we have same exercise but non-merged. It's much difficult. And third exercise is a different place, and that measuring how to students understanding what they learning about after other one exercise. And when we get the data in a simulator, take automatic feedback, and student or teacher and must be understanding to climate resilient what do's that they have done. But this data works also in right machine. It's very easy using right machine. It is simulator data is much difficult to take, but it's a real machine that driver helped data, because we have XML format. We can separate to AI that kind what we need to see about driver. It's helping very much about forest machine, real machine driver.
Okay, and as a machine manufacturer PONSSE, we are very happy to be able to be part of this project what Janne and Tredu has been building up. This is very important also for us as a machine manufacturer, that we can provide the best service for our customers. Because as everybody we know these days, the sustainability, environmental issues, they are very important. But also, we need, also in the future, we need paper, we need sawmill products, but we have to do it in a clever way. So we all these kind of features, what we can use afterwards in a real life, and supporting and helping the operators to work more clever and a more sustainability way. Also, right working methods means also the less emissions. So these are very important points also that, and we want to provide them also for our customers. And also the safety issues is also very important, and all these things we can put together on the simulator trainings and this kind of digital twins will be in the future certainly one of the point how we can train even new operators, but also for the professional operators, because we can cut the same trees again and again and again, and we can see always the differences. So we generally we do that already quite a lot, and we have a very good talks with the operators and the key point is always that we try to bring the message for the operators that work smarter, not harder. So this makes your production, emissions and efficiency and the sustainability all packaged together.
Yes, I think it's here. Thank you.
So much. Is there any question from the audience?
Yeah, hi. So can you go back to the last slide, please? So I want to ask, how long does it take for you to go from step 1 to step 5, like taking the data for the multispectral camera and converting into the XML format? How long does that take?
Actually, computer calculated this about 2 weeks.
Okay. And when you say that in the step 2, different layers are obtained through from the forest, so what does that mean by the different layers? Like, is it like from the top and then from the ground surveillance, or like what are the different layers means there?
Sorry, would you clarify once more?
Like in the step 2, it says that different layers are obtained from the forest, right? So what does different layers means there?
These ones.
Yeah, what are these?
Pääräväri, ilmakuva ja lidari.
Color means about the photo.
Oh, the
Color indicates about the different things on there.
okay,
Like
okay, yep.
Yeah, 3 species.
Okay, and you say on the step 4 that you separate the species of the trees with the help of AI. So, which AI models are you using there, and is it your own proprietary model, or you are using the open source model?
Red one is spruce, and pine is red, but little bit red, and softwood is blue one.
Okay, but I'm asking like what models of AI you are using there? Is it a CNN, a neural network, or machine learning based thing?
It's machine learning.
Okay, okay.
It's part of Helsinki University. What they done? We built this learning environment, and our project is partner of PONSSE and Helsinki University, Argonaut, and this project is luomuhakkuu in Finnish.
Okay, thank you.
Yes.
Thank you. Any other question? Otherwise, thank you so much for your talk. And I guess we will have a short break, kind of 10 minutes, up to the next talk. Thank you so much.